Vamos a arrancar este evento con un orador de lujo. Él es un ícono referente de la tecnología, John Maddog Hall, que es el creador de Linux. Él se vino especialmente desde Estados Unidos para explicarnos todo sobre open source. John Maddog Hall currently is the board chair of the Linux Professional Institute, co-founder and senior advisor to Caninus Locus, the president of Project Kawa, and the executive director of Linux International. Mr. Hall has traveled the world over 100 countries, speaking of the benefits of the free open source software, and this won't be deception. Así que, por favor, un gran aplauso para John Maddog Hall.
Thank you. Start. Buenos dias, campuseros. Unfortunately, that is the last Spanish you'll hear out of me today. Because while I know many computer languages, my ability to speak human languages is limited. My talk today is called Free and Open Source Software, Hardware, and Culture Can Do It All, and it being IT. I would like to dedicate this talk to two people. The first one is Alan Turing, who was a cryptographer and a mathematician, and who broke the German Enigma code in World War II. He is considered to be the father of computer science and artificial intelligence. And he saved about 14 million lives in World War II and shortened the war by 2 years by breaking the German Enigma code. I would also like to dedicate it to Rear Admiral Grace Murray Hopper, who's considered to be the first modern-day computer programmer. She did this in 1943. Why aren't I not seeing the slide up there? The clicker, I have clicked it, and it should be, there it is, okay. She programmed the Mark I and Mark II computers at Harvard University, which were used for ballistics, shooting big guns and shells long distances. She programmed that in machine language, the ones and zeros that the machine could understand. And she felt that somehow we should be able to teach computers how to learn human languages. And they laughed at her. And she went on to invent the language COBOL. And later, she rose to the rank of Rear Admiral in the United States Navy at a time where women were not considered to be people who could be in the Navy. So ladies out there, if some man tells you you can't do something just because you're female, they're wrong. So in the early days, 1945 to 1969, hardware was fantastically large physically, but very small logically. We measured memory in kilobytes, not in megabytes or gigabytes. It was slow by today's standards, 100,000 machine cycles per second. Today, we do 1 billion, and that's just one core. Networking was more or less non-existent. You had boxes of cards that you would carry down to your friend. Security was locking the door at night because there was no internet. And graphics was ASCII art of maybe some dog lying on top of a doghouse. Also in the early days, I have to keep watching this because something is wrong. Also in the early days, I'm still not. Uh-oh. Hopefully this will do it. No, it's not. There it is. Also, which one? Yeah, but I'm hitting that one.
No, this.
This, okay. Also in the early days of 1945 to 1969, there were few professional programmers. Most of the people who wrote programs were physicists or chemists or electrical engineers. They weren't people who wrote programs for somebody else. They wrote programs for themselves to be able to do their own work. And therefore, once they had written the program, they say, well, what am I going to do with this? There weren't as many computers. There wasn't a market for software. So they gave the software away, sometimes to user groups like DECUS or Share. And these groups would redistribute the software to people who needed them. And so the idea of sharing your software and sharing your capabilities and helping somebody else out was there in the community. I even had a professor tell me at university, John, you'll never make a living as a professional programmer. And now, 50 years later, I'm still waiting to find out if he was right. So my personal history was that I started programming in 1969 when I was at university. I was going to be an electrical engineer, but I was almost electrocuted, so I went to programming, which was safer. I joined up with this group named DECUS. That was the Digital Equipment Corporation User Society. And when I wrote software, I would contribute it to DECUS, and I would get my software from DECUS. And of course, it was in source code. I went to work for the largest insurance company in the world, Aetna Life and Casualty. We were the largest commercial user of IBM equipment in the world. And we got all of the source code for everything we did. And oftentimes, I would have to go in and fix the operating system or fix the compiler to make it work the way it was supposed to. I went to teach at Hartford State Technical College. Many of my students were like you, except they had never seen a computer in real life. They had never touched a computer keyboard. And I took them from there to being able to write a simple operating system or a simple compiler or a simple database in a 2-year period of time. And again, DECUS supplied a lot of the software that my students used so they could see how other people coded and how other things worked. I went to work for Bell Labs, who invented Unix in 1969. And of course, I had all the source code for Unix. And sometimes I would have to go in and fix programs in Unix myself. I went to work for DEC, Digital Equipment Corporation, in 1980 to 1999. And it's there that I met Linus Torvalds and convinced him to take Linux from being a 32-bit system to a 64-bit system. And what does that mean? It means that instead of only being able to store 4 billion bytes of data, you can now store 4 billion times 4 billion bytes of data. And how much is that? That is 32 bytes of data for every square millimeter on the surface of the Earth, including all the oceans. That's how big it is. And it's literally a size that you can solve almost every problem we will ever have. And from 1994 until now, I've been going around the world talking about free software. And not freedom as in free beer, not free software as in free beer. It's not about the cost of the software. It's about the freedom that you have to do anything you want to with it. That is what it's about. And so now, you can get a very capable computer for $35, the Raspberry Pi. 4 cores, 8 gigabytes of RAM. And you can get free and open source software for almost anything you want to do. Various operating systems, micro core processors, microkernels, regular monolithic kernels, BSD, Linux, You can see how they work. You can change them to do what you need to do. There's over 400,000 free and open source projects out on places like GitHub, SourceForge, GitLab, and others. And it's not just operating systems, it's compilers and databases, high-performance computing, supercomputers, all this type of software you can get with the source code. There's even open hardware now. You're familiar with Intel and ARM. Those are proprietary chipsets owned by a company. They tell you what to do with them. But there's a new one out from the University of California, Berkeley, called RISC-V. And it's a new architecture, and there's a group of companies and universities and professionals working together to eliminate the mistakes that we made with Intel and ARM and others. And it's a free and open architecture. You can implement this using an emulator or an FPGA, and you can see how it works, and you can contribute to it. There's also free and open culture, free music, free text, free graphics, free pictures under the Creative Commons license. And at the bottom of every single one of my slides, you see a Creative Commons license that says, yes, you can use this talk without having to ask me. Yes, you can distribute it to others. You can't change it because I don't want you taking what I say out of context. But if you want to, you can come back to me and say, I'd like to use a portion of your talk, and I will grant it. And there's also interesting ways of making money to start your business, to start your project, whether it be things like, I'm having a mental blank now. Indiegogo, there we go. Indiegogo or some of the other free software ways of generating money for projects. Now I'm going to tell you a secret. Nobody ever really buys a computer. Unless maybe there's Steve Wozniak, he'd be happy to buy an Apple One. And nobody ever buys software unless it's Larry Ellison, who owns Oracle, he'd be happy to buy software. What they buy are solutions to problems. And even if that problem is trying to talk to each other, and you can do that with 2 tin cans and a string, that's what you would do. It just so happens that computers are very good at doing all of the things that we need to do. But what people want now is a solution to their problem. And with free and open source software, you can have many different types of solutions. I'm going to introduce you to 4 of them today that you could create, and you could sell a product, and you could maintain it without having to ask anybody's permission. The first one is called Odoo. It is an enterprise resource program, planning program, ERP, and a point-of-sale system. Every time you walk into a McDonald's or a small grocery store or even a big grocery store, you see a point-of-sale solution. It is a scanner, it is a scale, it is an LCD panel, it is a cash drawer, it is a printer. And they probably bought this from some large company like Oracle or Hewlett-Packard Enterprise, and they paid thousands and thousands of dollars for it. But the worst part is that it's closed. You can't change it. You can't make it do what you want it to. But you could buy the component yourself, and you could put it together. And you could sell this to customers, and you could maintain it for them and make it do exactly what they want it to. And my company, LPI, actually uses Odoo to run its entire system. Everything we do is done through Odoo because we have control. That's a picture of part of an Odoo system up there. The little printer, the LCD panel, it's a touch screen, just like you see at a supermarket. And you can do this, you can put this together and you can sell this to people and make money. Kodi TV is a multimedia entertainment system. Many of you have seen smart TVs in stores and things. A lot of them are using Kodi as a software for their smart TV. But you could put together a system yourself just an LCD panel, not a smart TV, and a little single board computer like a Raspberry Pi to be able to do even more than what the things do in the stores that you buy. And you can maintain it for people, and you can change it to meet their needs, and you can charge money for them. Here's some of the things that Kodi does and the screens they can put up. Very nice looking, aren't they? You can make it and change it. You can use even their existing remote controls to control it. You can also capture over-the-air TV channels that are still being used. Not everything comes through cable. Over-the-air TV channels to give people free TV with their Kodi system. And you can set up a back-end server to save their videos and their music and things like that and distribute it throughout their house. All of this could be done at a fraction of the cost of the things you buy in the store and be way more flexible. You can use their existing TV remotes, or you can even use a smartphone to control it. You can set it up to use touch screens instead of having to use a keyboard. But if you want to use a keyboard, that's fine. You can also use game consoles to control it. If they want to spend more money, you can get a digital amplifier. Now, back in the old days, when I was growing up, everything was analog. You had an analog tuner that would tune in your station, and you had an analog mixer that would mix the music, and you had an analog equalizer. It was all very expensive. Eventually, you'd feed it into an analog amplifier and go out to your speakers. Today, everything except the amplification can be done by the Raspberry Pi digitally. At the last moment, you stick it into your digital amplifier, and you have it digital from end to end at a fraction of the cost that we used to pay. And you can get an LCD projector and project it up on the wall to have a very large TV screen. If you're concerned about security and privacy, and you should be, there is a project on the net called Freedom Box, started by a friend of mine by the name of Eben Moglen, who's a lawyer. He also wrote GPL version 3, the GNU Public License version 3. And Eben was concerned about the fact that everybody was putting all of their secret stuff up on Google and Amazon and Microsoft. Now, I come from the United States. I am a US citizen, and all of my rights are protected by our Constitution. If you believe that, I have a bridge to sell you. No, but it's even worse for you because you are not US citizens. And every time you send something to Google, every time you send something to Amazon, every time you send something anyplace to the United States, we're watching you, and you have no protection whatsoever. So, you should be storing all of your secret data on something like this that you keep in your house. You plug it into your wall, and you build a proper firewall to protect you. Guess what? It comes with the firewall. It comes with the Tor server. It comes with a web server and all of that thing. And it's much easier to set up than you would if you did it from scratch. And this can actually, it says a personal server, but it could actually be a server for your friends, your community of friends that you want to do things with, and you don't want somebody staring at what you're doing. It can be used as a NAS server for the files in your house to distribute your files to all of your computer systems. And the software is free. And the hardware could be something like a Raspberry Pi with this little box right here that has absolutely no binary blobs in it. You can see every piece of software that's running on your system. What about home automation? You'd like to control your home. Well, you could get Google Home. Oh, that's wonderful. Okay, Google, turn on the light. Turn off the light. You know, turning on the light with Google Home generates thousands of bytes of data that mysteriously have to go to Google every once in a while. I don't know why. You're just turning the light on and off. Why do you have to send thousands of bytes to Google to do that? Another thing is, what happens when your internet goes down? Yeah, nothing can get to Google, and your lights just stay dark. It's a terrible feeling. But hey, you could use Home Assistant, and you can put it on a little Raspberry Pi or other single-board computer, and you can now control your house just from your house. So if your internet goes down, your lights still go on and off when you tell it to turn it on and off. That's a good thing, okay? But you can also sell this to people. You can sell it to small business and can let them control their electricity. Let them cut the costs of the electricity by using home automation. I am working on projects now. I'm 72 years old. I've had 2 massive heart attacks. I only have 50% of my heart left. I can't see very well, which is why I walk slowly up and down the steps. But I have 2 projects I'm working on that I think are important. One of them is called Caninus Lucus, and I've been working on it for 6 years. I'm working on it with the University of Sao Paulo in Sao Paulo, Brazil, because I said to them, why are you sending billions of reais every year to China, to the United States, and to Europe, when you could be using those billions of reais to pay local Brazilians or Argentinians? Huh? Why are you doing that? Are you too stupid to be able to do this work? No, of course not. You have women in your population. Okay, so they said, that's right, maybe we should be doing that. Maybe we should make our own little computers. And so we started a project, and now 6 years later, we're actually selling them. This is a non-profit product, non-profit thing, because we're not here to make money. We're here to create jobs. And we're here to create security. And we're here to spread how to do this type of work inside of Latin America, and not China, not the United States, not Europe. It's not just little single-board computers like this, but it's actually computers that are much smaller. I should have gotten this out before the talk, but I'll get it out now. Can you see this? Of course you can. This is a little computer which we call the Pulga. This computer is called the Labrador. We name all of our computers after dogs because Caninus Lucus means crazy dogs in Portuguese. Well, this is the Pulga. We almost named it the Chihuahua, but we realized that nobody likes Chihuahuas, so it's the Pulga because all dogs have fleas. And this little computer, we want to have a target price of under $1 US. That's about 270 pesos. Because we want farmers to be able to scatter these computers in their fields to determine when their crops need moisture, to determine when they need fertilizer, because fertilizer and water cost money. And fertilizer goes into streams and creates algae and other bad things. So if you put on just the amount of fertilizer you need, you can cut down on environmental pollution. Plus, a lot of modern-day fertilizers are made from oil, and we're running out of that. So this was developed completely at the University of Sao Paulo. And we want to teach the students how to make these. I am going to be working with Argentinian universities to also make this type of electronics, so you can have this type of power. Because what happens if China gets mad at Argentina? What happens if they cut off your supply of little computer parts? That's very bad, because it used to be, back in the days of Grace Mary Hopper, that we could send the astronauts up into space using slide rules and calculators. But today, if computers were to stop flowing into Argentina, planes would fall from the sky, your traffic lights would stop working, and there would be chaos. So you have to control your own destiny, and that's why I am here. I am also working on another personal project, that of Project Kawan. In Latin America, as you know, most universities are free of tuition. That means if you study hard in high school and you get admitted to the university, you do not have to pay the hundreds of thousands of dollars that we do in the United States. However, 40% of the students who are qualified do not go to university because a lot of times their families are too poor to pay for the apartment that is needed, the food, the internet, the books, the computers, and things like that. And so sometimes the best students cannot take advantage of the free tuition. So I thought to myself, how can I help students who need that money to go to university? Students, how many of you, I'll do this right here, how many of you have ever changed a disk drive in your computer? Don't be afraid to raise your hands. Please, raise your hands if you have. How many of you have ever installed a new version of the operating system on your computer? How many of you have ever set up the networking in your house? How many of you have ever helped your parents do this when they know that they can't do any of it? And your neighbors? This is true of many of the students who study computer science and computer engineering to go to university. They've been doing this since the age of 8 years old. I know because I married a Brazilian who had done that. And so we're going to teach the students how to start their own company and sell their services to small business people who don't know how to do these things but have to use computers. And that's what Project Kawan is about. We are going to provide free of charge sample contracts, marketing materials, and a mentor to help them understand how to do this. It's going to be a part-time job, maybe 26 hours a week, and so the students may stretch out their courses so that they can do it. It may take them 5 years, which is a much shorter time than never. And they're going to use their already existing technical skills. We feel that this project will allow the students to make enough money that they will be able to have a decent life at university. Now, people ask me all the time, Maddog, what are the areas that we should be watching in the future? What should we be studying? What should we be looking at? And my first word of education to you, or advice, is don't just think that because you know how to program Java and you can write some HTML that you're a programmer. You're not. You need to be able to understand how the computer works, which means you need to be able to understand how the hardware actually interprets the ones and zeros of machine language. That's how you become a real programmer, because you understand how the computer works. It's not that hard. You can do it. Assembly language is the second language I ever programmed. The first one was Fortran. But I learned how the machine worked, and that meant that I could understand how a compiler worked or how an operating system worked. And it meant that nothing was hidden to me. So you should understand everything down to the very bottom and then everything up. And if you understand that, then there will be nothing which will be impossible for you to understand. University is not there to teach you how to get a job. Surprise, university professors don't care if you get a job or not. What they're there is to teach you how to learn on your own, to learn from books, magazine articles, internet postings, and how to sift through all of the crap of data to produce the information which you need to solve the problem. This is true throughout your life, by the way. Right now, Brazil is going through a very bad electoral season. 2 very strong candidates up for election. One of them is well, I won't say the word because this is a polite audience. And what they need to do is to sort through all of the crap which is being spewed at them and to think about it. And then they will make the right decision. You have to do that with computer science too. So what things should you be watching? RISC-V architecture is going to be the new architecture that's going to replace a lot of the other ones. There's a lot of Intel chips out there, there's a lot of ARM chips out there. It will take a long time, but ARM is the way to go. RISC-V is the way to go, I'm sorry. High performance computing. People say to me, Maddog, do you like computer games? No, I'm not a gamer, sorry. I don't like games, I don't like programming games, not of interest to me. What interests me are the very, very, very small things which have to be done very quickly. Your nuclear power plant is melting. Lower the rods. It has to be done now. You don't get a second chance. Otherwise, it's Chernobyl. And then the very big things. Weather forecasting, analyzing DNA, looking at the genome, petabytes and terabytes of data. That interests me. Everything else is boring. But high-performance computing and the problems it solves are the problems that we need to solve before the Earth becomes a cinder. Cybersecurity. Every time we turn around, somebody's breaking in and stealing another $1 trillion worth of Bitcoin. We need to keep our things safe because more and more governments are funding the people who do the break-in to bring down your electric grid, to attack your power plants, to create havoc. We need cybersecurity, unfortunately. Artificial intelligence. All these people that say the computer will never replace me, they're wrong. Remember I said that Alan Turing was the father of artificial intelligence? He knew how to do it. It's just his computers were too slow and too small. But they're not too slow and too small anymore. And we're getting closer and closer to artificial intelligence. And someday we will have an artificially intelligent thing that will replace lawyers. Can't happen too soon. And already they're helping doctors analyze what's wrong with you, get it down to 2 or 3 things which they can then investigate. Already it's doing legal work, and it's only going to get stronger and better. And we have to be able to figure out what human beings are going to do with that artificial intelligence. Are we going to use it for good, or are we going to use it for evil? And I advise people, never create a computer that's so powerful that you can't unplug it. And finally, quantum computing. which I quite honestly try and stay as far away from as I can, because I'm 72 years old now, and if I can die without ever really understanding quantum computing, I will be happy. But for you, it's something you should look at, understand, and maybe get a job in. So I was asked whether I wanted to do questions and answers from up here on the stage or later. I would like to be later, but I will be around until about 3 o'clock when I have a meeting. I will go away and I will come back, and I'll be here till 9 tonight. So if you have questions, please come up and ask me. Don't be afraid, and don't apologize to me because your English is bad, because my Spanish is, well, I said it at the beginning, buenos dias. I can also say buenas noches. And I can say cerveza, beer. But thank you very much for attending, and I hope you have a great rest of the campus party. Thank you. Let me off. But I will say that I'm going to pack up my things and I will go over there and I'll talk with people if you want to ask questions. Thank you. Oh, they said we have time for some questions, so if they have a microphone to take around. Anybody have any questions now?
Tenemos unos minutitos, así que, a ver, por ahí tiene unas preguntas.
Hi, Maddog. My name is Alan, and a question for you. What do you think about the metaverse?
I think as long as the metaverse is under the control of somebody like Mark Zuckerberg, we have problems. I would like to see the metaverse be completely free and open source software and have much more people contributing to it. Quite frankly, I prefer living in the universe rather than the metaverse.
Thank you.
Hello. Could you talk more about cybersecurity?
Okay, so let's start with the Freedom Box, because the Freedom Box is built completely with free software. There's no binary blobs in it, so there's nothing which you can't investigate or see what it's like. Linux itself was built to be a secure system. Unlike early versions of MS-DOS or early versions of Windows that didn't even have a password on the system, they were built for a single person. They were built before they were connected to the internet. Over time, of course, they've been made to be much more secure. But Unix systems were built from the very beginning to be a multi-user system, which meant that they had to have protections from other users going in. And over time, people have built ever stronger versions of security in Unix systems. When Linux came about, the NSA, the National Security Agency of the United States, created a type of framework for security of Linux called Linux Enhanced Security. And they developed that and published what they were doing so that people could look at it, make comments on it. Now, it seems strange that an organization like the NSA would want to have a secure system. But remember, they need security too. So they wanted to be able to have a system that they could use that would be secure and would be open source so they could see everything that was going on. There's another type of security model called AppArmor, where it isn't as invasive as secure Linux is, and it's done on more on an application by application basis. It's built around a structure called PAM, which is an authentication by module basis. So you can set up the different types of authentication that you want in each and every module or piece of program inside of Linux. Now, I switch back and forth between cryptography as security and encrypting all of your stuff and authentication. Because in reality, much authentication uses cryptographic techniques. So as an example, if I want to make sure that I'm talking to you, I use a cryptographic key that is a public-private key pair. And I encrypt my file with my private key so that you can decrypt it with my public key. And therefore you know it came from me. If it decrypts, it had to have been encrypted by me, therefore you know I sent it. Now in order to protect it, I take the encrypted file and I re-encrypt it with your public key, because then you're the only person who can decrypt it. And that protects it while it's being transmitted. So this is authentication and protection using encryption, which is very important. And Linux has open source encryption methods so you can see how they work and that you understand that they're doing it correctly. On top of all of these, some of the first firewalls were created with Linux systems. And so there's this huge layer upon layer of encryption and security software that goes along with it. In another talk, I talk about the various levels of security and encryption built into Linux systems. And FreedomBox uses a large number of them. But another thing that you may want to use is multi-factor authentication. So in your first level of authentication, you have your simple login name and password, but they aren't very good. So sometimes you want a second level of encryption to say, oh, I'm trying to use this service. Now you send me a message somehow, either a text message or you call me and you tell me that I need to send back to you a code which that you have sent to me. And that's a two-factor authentication model. But you can have multi-factor authentication models. You can say the only time that this application can be used is between the hours of 9 a.m. and 5 p.m. Monday through Friday. If it's used at any other time, it's not me. Don't allow it to happen. You can use your fingerprint reader on your laptop or your phone to be another level of authentication. You can use facial recognition as another level of authentication. So through all of these things, you create a much, much more secure system. You should always be using encryption to any connection that you do. A virtual private network, you should always be doing that if you're going across the internet. And even if you're only communicating between a laptop here and a laptop on the table next to you, you don't know where those packets are going. They could go all the way back to Google and back. You need to be able to encrypt them. There's so many levels of authentication and security issues that this is a big area. There's going to have to be a lot of people knowledgeable about it to help customers set up a very secure system. Did I answer your question?
Yeah. And could you tell me the difference about software and hardware?
I'm sorry, I didn't hear the last part. What?
The difference about hardware and software.
The difference between hardware and software? Okay. Once upon a time, hardware was the resistors and capacitors and transistors and things that go into actual making the computer. Over time, some of these things were replaced by something which was called firmware, which was software that was compiled to act like hardware. And examples of this were things like the Win modem, where once upon a time, a modem was very expensive, had a lot of parts to it, and it didn't need any software. But later on, to cut down on the cost of modems, they built them into the computer and allowed the software to do a lot of the work that had been done by the hardware before. Unfortunately, this meant that the modem was now tied to a particular operating system. And so firmware creates a problem in that, and when you upgrade your operating system, your modem may stop working. So then there's software, which is the high-level information or programs which drive the rest of the operating system. So the operating system is typically made up of a small center core called the kernel that does a few things very quickly. It schedules a task, it schedules memory, it schedules I/O devices, input, output, and those are things that the kernel does. On top of that, you have libraries that do a lot of the other extra things that you have, like creating a character or putting your graphics up on the screen. And then on top of that, you have utilities and programs that either use the libraries or use the system calls to the kernel to do everything that you want with your computer. And all of that is software. Did I answer your question? Okay, I'll assume I did.